Okay, these word problems are kind of like puzzles, and I do tend to like these because they have lots of aha moments. You're like, aha. And it makes connections with what we've done in previous with the differentiation. So, but this time we're going to be given marginal cost information, and we're going to have to go backwards and find the total cost. So here's an example. Marginal cost for producing X units of a product is modeled by this function. So dC dx is equal to 32 minus 0.04x. So that's going to be given. So this is given information. So here's our marginal cost for producing X units of a product. It costs $50 to produce 1 unit. Now, $50 to produce 1 unit, that's an initial condition. That's going to help us write a particular equation. So we've got that initial condition. We want to find the total cost of producing 2 units. So find the total cost. That means we're going to have to find the cost function. Evaluated at x equals 200. So that's what this part means right here. So let's get started. Our first step is to integrate, to go backwards, integrate dc dx, to go backwards, and I'm going to show you something pretty cool here. So I didn't say it in the other videos, but I'm going to say it right here. We've got dC dx equals 32 minus 0.04x. I'm going to integrate. So I'm going to integrate both sides, but before I integrate both sides, I'm going to multiply both sides by dx. Okay, so now we've got dc is equal to 32 minus 0.04x dx. I'm going to integrate both sides. This is pretty cool. This is pretty cool. Integrate both sides. Well, what's the indefinite integral of dc, or the integral of dc? The antiderivative of dc is going to be c, right? Now, any constant, this is cost, okay, not a constant c. This is a variable c. Now, any cost, any constant that might be on the left-hand side, we're just going to move it over to the, or to on the left-hand side, excuse me, any constant, let's just say plus k, some constant k, okay? I'm going to incorporate that constant k on the right-hand side when I integrate. So I don't have to, remember, when you integrate, you don't have to put the constant with each term of the integral. You can just put one constant at the very end, and I choose to do it on the right-hand side. So now I've got to integrate the right-hand side, and that's going to be 32x minus, we're going to have 0.04 divided by 2, so 4 cents cut in half is 2 cents, x squared. So 32x minus 0.02x squared, and then I've got a constant, but because c already stands for cost, I'm going to have to use k for my constant. C stands for cost in this problem. Therefore, we use k for the constant. This way we don't get confused. You can't use the same parameter, the same variable twice for two different representations. Now we're going to go to the initial condition. So now that we've got this general equation, we're going to use the initial condition. And the initial condition said $50 to produce 1 unit. So when x equals 1, c equals 50. So we put a 50 in for c, a 1 in for x, and now we have one variable left, or parameter, that we need to figure out what that is. We have 50 equals 32 minus 0.02 plus k. $32 minus 2 cents, that would be $31.98, right? When you're dealing with money, it makes a lot of sense. Oh, I cracked myself up. Okay, 1802 equals k. So our cost function is 32x minus 0.02x squared plus 1802. Now, what was our third step that we wanted to do? We wanted to find the cost function. I'm going to erase this one. We want to find the cost function evaluated. I'm going to use that same green though. Evaluated at x equals 200. So c equals 32 times 200 minus, I'm going to make this 2 100ths times 200 squared plus 1802. You can tell I'm being very stubborn right now. I do not want to pick up a calculator. 32 times 2 is 64 plus 2 zeros minus 100 goes into 200 2 times. So 2 times 2 is 4 times 200 is 800. So 6400 minus 800 plus 18.02. So I believe that that's going to be 5600 plus 1802, which would be $5,618.02 would be our total cost. Total cost for 200 units. Now, if that didn't knock your socks off, I don't know what would. This right here is super cool stuff. Super cool stuff. That's why the differential has to be, that differential has to be on the right hand side. So when I've got that dc dx, I need to, before I integrate both sides, I need to move that differential to the other side. Then when I integrate, right, I'm just integrating dc, which is c. It's one of the coolest things since sliced bread. The way math works, it's just amazing. Amazing. Lots of cool things happening around us.